Hello and welcome to the TechGig podcast. Thank you for tuning in. I am your host, Sukriti Adivanshi, and today I'm here with an episode on how product design linked incentive or PLI and design linked incentive, or you may call them as DLI schemes, will help India in becoming a manufacturing hub. Before we move to the conversation with our special guest today, what are actually PLI and DLI schemes? So, the Union Cabinet approved a rupees 76,000 crore program for development and deployment of sustainable semiconductor and display manufacturing ecosystem in the country. Now, this amount will be spent on these projects in the span of 6 years. A product design linked incentive that we talk of is reimbursement of up to 50% of the eligible expenditure subject to a ceiling of rupees 15 crore per application that will be provided as fiscal support to the approved applicants who are engaged in semiconductor design for integrated circuits, chipsets, system on chips, systems and IP cores, and semiconductor link design. The second one that we speak of, a design linked incentive, is also a scheme which will offer financial incentives as well as design infrastructure support across various stages of development and deployment of semiconductor design for integrated circuits, chipsets, system on chips, systems and IP cores, and semiconductor linked design over a period of 5 years altogether. Now, to elaborate on this further, I am elated to welcome Sanjay Gupta, Vice President and India Managing Director from NXP India. Welcome to the show, Sanjay. I'm very pleased to have you here with me today.
Thank you so much, and I'm equally excited to be part of this show and looking forward to a very engaging discussion. Thank you for having me on the show.
Thanks, Sanjay, once again. So I cannot wait for you to share the right kind of insight that we're going to talk about and the entire evolution that will happen under this scheme when we speak of DLI and PLI altogether. So let's begin. So my first question for you is, what are the scheme announcements, garnering investors' attention?
Right. So before I do that, I would also mention to you, one of the founding principles why this scheme is being launched, across India with such a big fanfare at the beginning of this year. I think your audience would love to know, that India as a country is one of the biggest and fastest consumers of electronic goods and related gadgets. And this is only growing as the income level in the country are increasing, and we are getting more and more usage of every single electronic gadget that we can think of, from mobile phones to latest TVs to all the broadband equipments, the routers, and whatnot. And this is creating a big electronics import in the country. Now we have to be aware of a global fiscal situation that at the moment India's oil import is one of the biggest drain on the country, to the extent that with a $10 increase in the oil price results in a significant percentage of our fiscal deficit to get impacted. Now imagine the way our electronic imports are going up, most of which is coming from other countries. In no time, based on all the predictions, this electronic import will cross the oil import. And I think it is but natural to assume that if that happens, how this can negatively impact country's economy, where we will have not just oil but also the entire electronics and semiconductors being a big drain on the country's fiscal deficit, because we will be importing much more than we are exporting. Right? So to address this fundamental challenge, which will be very, very important for country's future growth, the Honorable Prime Minister and the government has tried to ensure that through a very focused schemes, we divert the entire electronic and semiconductors import and turn it around as the local manufacturing of these smart electronic products. And that's where the ESGM sector is poised for a very big growth. To enable it happens, it is being done with this DLI and PLI schemes. And that's where the genesis of these two great schemes that just happened are going to be a disruptive change in the Indian in the Indian history. That's what I believe. Now, what is a DLI and what is a PLI? So very simple way, the DLI would mean the more you design, the more incentives you get. The PLI would mean the more you produce, the more incentive you get. for a layman. Now, how we are going to do that as a country? So the bigger of these two schemes for sure is a production linked incentive or a PLI scheme, where other than different factors around PLI, which government had opened up even last year, which was going into, say, chemical sector or textile sector or many other electronic ecosystem, be it tablets, be it the network infrastructure, be it the mobile phones. The most significant piece of that has happened, a few months back, is the policy for semiconductors manufacturing. And as part of that, if you are putting a fab in place, which is supposed to build the entire wafers and the entire ecosystem around it, you can get up to 50% of the overall project cost. Now, the important factor is overall project cost, not just the cost of tools, not just the cost of any specific hardware. In a project cost, it would mean completely under the hood of the project, your buildings, your facilities, your R&D, your engineering, your travel, your the entire 360-degree yard of activities are included, and that is one of the most attractive schemes that I can tell that has happened across the world. It is one of the benchmark schemes where 300 wafer fab size with installed capacity of 40,000 plus wafers. I think that will be really a game changer for India's semiconductor ambitions. Now, if we go to the second part of that scheme, that is for the the peripheral activities around that, which have compound semiconductor and ATMP, which is automated test packaging and manufacturing of the whole ecosystem, which is also called as the backend fab. So a front-end fab which designs the entire wafers and produce chips, a backend fab which converts those raw wafer chips into the end product. So your audience, if you know about how a chip looks like, it has literally legs and a plastic package over it, where you would have seen some of the company's name on top of that. That is what we see into our computer motherboards or a mobile phones if we have opened it, inside, how the electronic board looks like. Now, these packaged products are the ones which are used into the end applications. And it's a complete industry in itself, how to convert a raw wafer coming out of the fabrication and then package it with the plastic and the legs, which can get inside the board. And if we set up this kind of a ATMP, we will get up to 30% of the direct benefit on the overall project cost. And again, the wafer size could be 150 or 200 and installed capacity of 500 plus wafer size. The technology could be flip chip, embedded die size, and the multiple variants around the SIP and chiplets. So this is again a great way to increase the overall ecosystem of semiconductors in the country. And for that, the investment levels are relatively lower. For the front-end fab, wafer fab, a minimum capital investment of $3 billion will be required by any company who wants to come forward. However, for the ATMP or a back-end fab, the amount of investment is much lower. They are in the range of less than $20 million for a compound fab and less than $10 million for the ATMP. And finally, the third and most important element, which is directly linked to innovation, which is directly linked to the R&D, directly linked to design activities, is the DLI, Design Linked Incentive Scheme, where if you are a startup, if you are upcoming, small company aspiring to be the big leader in times to come in technology area, up to 50% of the eligible expenditure will be given as a subsidy by the government. And there is a cap of $2 million, which in Indian rupee will be more than 15 crore rupees that will be given as part of this incentive, which I believe is very attractive. And that will enable a lot of startups, a lot of aspirational, fabulous design houses who have a vision to create a big IP which can compete with the best microcontroller or a microprocessor right now being provided by, say, one of the world-class MNCs. So that will pave the way for Indian entrepreneurs to explore this horizon of design and R&D and go for either the IP creation or go for the entire system on chip product development through the ASIC tape outs, and really get inside this niche area which right now India has a very little space to play with. So overall, I think these three schemes, the front end wafer fab, the back end ATMP fab, and compound semiconductor fab, and finally DLI. These are the three pillars on which the Indian semiconductor future is going to stand up and really prosper forward. And one last thing I would like to add is these are only the central government supports. On top of it, there is a very healthy competition with all the state governments for the land, water, the power infrastructure support, the better taxation and the better ease of doing business policies which are rolled out by each state government, and they are going to further benefit all the entrepreneurs and all the industries who want to come forward and invest into this progressive government scheme. I will pause here and probably discuss more things as we move forward in the discussion.
Sure, Sanjay. So, the kind of elements that you've introduced our audience to when it comes to actually the announcements regarding the schemes. Now, moving further, when you speak of the startups and their growth, I'm sure the entire startup ecosystem is being boosted by the government. And as we know of Atmanirbhar Bharat and our honorable Prime Minister's, vision of taking startups and building that ecosystem of powerful startups, I should say. So help me understand that how these schemes will actually help in fulfilling PM Modi's vision of Atmanirbhar Bharat altogether.
Absolutely. I feel this really goes right at the core of it. One of the biggest critique, that India used to get in for a long time was our government is not sensitive to the local needs. We are not listening into the ground level people, what changes we need to bring into the policy and procedures and ease of doing business, so that a common man can think of opening their companies. A common man can think that it is not the game that can be only played by a big industrialist. It can be done by a simple man in a village with a great idea and great vision. I feel, based on, I'm watching these developments very closely with Government of India, and I can say with very big conviction that this time government is extremely serious to make this dream a reality. Now think about it, a DLI program where government is asking through a nodal agencies like CDAC, and they have also created a very focused independent ministry under mighty independent nodal agency called ISM, Indian Semiconductor Mission. These two bodies, CDAC and ISM, are going to be driving these DLI and PLI programs in a much autonomous way than it has been done before. And based on that, if you have a startup which has the right product idea, a product could be the end product, a product could be a IP, a product could be a ecosystem, a component for a semiconductors design and development. Right? You have the opportunity to tap into this $2 million of subsidy, which is unheard of. I mean, I can bet in last 50 years there was a program that was offering $2 million of subsidies to the people who do not have the initial funding. And to do that, all you need to do is to convert your idea after you get into the approval stage with a prototype that yes, you're serious about it and your idea is not just on paper, but you have been working with some development that you can showcase to these nodal agencies. And during my meetings with the Minister for Electronics on multiple occasions, the Minister for State for Electronics, who are driving these policies, they have reassured us as industry partners that they will be more than happy if we can help some of the startups to come forward, and we can guide and nurture those startups, we can mentor those startups and really feel pride into this journey that is already started towards making India a semiconductors technology power in next 1 to 2 decades. We have our time, and I'm very, very confident about it.
Wonderful. So, Sanjay, startups are coming up with various technologies, and how will this scheme help these startups to mushroom in India?
So if a startup is coming into areas, and the area, so we have to think it two ways, for your audience. One is which domain these startups belong to, right? The domain could be, say, they are working towards a mobile domain. Mobile has a number of applications today for anything and everything, right from a tablets to a laptops. How we reinvent and invent these things to be more user friendly, to be more competitive, to be feature rich. It could be in an area which is related to, say, IoT gadgets, which are flooding the markets by various companies. Health is a big sector. We can have uh, focus on, say, uh, smart uh, electronic gadgets which can be embedded in your body, which can help you to track your body rhythms, and then automatically transfer these parameters to a central server, to your laptop, and then eventually to a doctor in an autonomous way. You can have a smart watches kind of a concept where the health focused youth of India would love to have these fancy little watches which can track everything from your sleep patterns to your uh, calories burned, and so many other things. Right? You can have the entire connectivity around 5G, and going forward, the world is changing with a lot of interconnectivity between cars and infrastructure. You have these Wi-Fi 6, Wi-Fi 7. You have the very short range communication technologies like NFC, ultra wideband, Bluetooth, low power. The world is right now kind of booming with newer and newer technologies, and we have a number of applications which we can build on top of those to create applications which help the society, as well as which makes the life more comfortable, and finally the more enjoyable, right? So automotive applications, you have or of electric cars, where the battery management systems, the smart and fast charging of these batteries is a critical challenge that the world is facing. Then you have a number of industrial applications where right from an industrial robot to a drone, everything require high-end electronics, right? Now, if youth of India has any one of these domains as their favorite domains where they are passionate about, and if they are using electronics and semiconductors as a horizontal to enable these application areas, right? These are the people who will get direct tap into this $2 million of subsidy using a DLI program. And once they have this subsidy money used to convert their ideas into reality, I mean, this is the way the startups can convert into next unicorns. Now, you think about the space today. India is one of the largest startup creator in the world. In fact, it is among the top 3 right now, based on the recent data. And most of the areas, where we enabled Indian youth, they are going after it. For example, the social media-based apps and websites which are really doing big. Um, there is a one unicorn is being created every few months in India in those space, whether they are into the online shopping area for either high-end gadgets, or to even the milk or vegetables procurement using a mobile phone, right? Everything is booming. Now, semiconductor is something that is the next big thing, because once we create a couple of role models, once we break this glass ceiling, that India can do that. If other countries can do that, India can do that even better, right? There will be no end to that. So all these applications are the big applications in a country like India, where we need medical, we need healthcare, we need remote education, we need, among the big farm fields in India, we need a lot of automation for the pesticides and fertilizers, which right now is a completely manual job. All this thing can be done very, very effectively to improve the productivity of these crops if you are able to manage it using drones and robots and automatic water and other distribution of these uh, farm related products. I'm super confident that there will be multiple entrepreneurs who are going to come out of this whole process, because now they have the first step uh, supported from the government. Right? $2 million is not a small amount for a startup if we really want to leverage that and if they are really committed to their cause.
So, Sanjay, you've all very well drawn the comparison of India with the other countries and the kind of developments that we, as a developing country, are trying to look at. Tell me, what are the challenges that needs to be overcome in the semiconductor industry for better power and energy management?
See, this is an area that we know historically India has been criticized for, that our infrastructure is not at par with those countries where the successful semiconductors wafer fab facilities are. Right now, we all know that uh, Taiwan right now is the world leader in having multiple fab houses which are driving the worldwide semiconductor production. Other than that, we have fabs in historically in US, Japan, China, and a few other countries, Korea, South Korea. And I believe that if you think about it, the amount of money that is required to build a fab, we are talking about anywhere from $6 to $10 billion for a decent fab. Now, I am very confident that if we go after this cause, having the challenge to guarantee uninterrupted electricity, pure water, and a good infrastructure near the fab, that problem can be solved in much lesser amount. If you do the math, we are talking about, let's say, give and take $10 billion, overall cost for advanced fab. So out of that money, we were doing some of the rough calculation that to create a uninterrupted electricity for a fab, it will not require us more than few $1 million, right? So percentage wise, in the overall scheme of things, the guarantee to create an infrastructure for the fab is actually very less in a percentage point. But I do agree it is a mental barrier that we have, that India does not have the right infrastructure. But whichever country you do and go deeper research into, I think none of the countries were made for a perfect infrastructure for fab anyway, until the government and the industry put their acts together and made it happen. So with the money not being a constraint anymore, I'm pretty sure the challenges of power and water, which by the way are huge component of a successful fab, but it is not impossible to make it happen, because money can make a difference. And today, money is not a constraint to make these two factors to be taken care of.
All right. So talking about technology now, that was the segregation that you mentioned about power and energy management, Sanjay. What is the role of technology in boosting the innovation and manufacturing in semiconductors?
See, technology. Now there are two angles to a technology. So one is which specific technology we are going to design these wafer fabs for, right? So that is one angle, which is linked to you can have 65 nanometer, 45 nanometer as one category, then you can have 28 nanometer as a second category, and then you can have even advanced 16 FinFET or even 5 nanometer as the most cutting edge technology, right? So these three are the semiconductors technology for which the fab proposal is out right now. And today, most of the worldwide chips that are made from a semiconductors technology perspective, they fall into one of these three baskets. Now, if you're the super cutting edge, the reality is that most of the products are under design in this super 5 nanometer, which is the latest cutting edge technology. And most of the products which are in use right now by masses, they are actually in the older technologies like 90 nanometer, 65 nanometer, or 45 nanometer, right? Because it takes time from a product to get from a brand new semiconductor technology, then get adopted by masses, and then in mass production for multiple years, because that is a sweet spot for that technology where the product can create a maximum amount of yield at the fab, which means least wastage in making the chip. Then this is the point where your technology get matured, so the cost of producing the per sample or a per wafer is the most optimal, and that's where the economies of scale happens, right? So that is a one angle of technology. And in India, my belief is to promote manufacturing, we don't need to be at the cutting edge, honestly, because there are two sides of a fab. One is the supply side and one is the demand side. We might create the 5 nanometer fab, right? But then once the chips are coming out, there needs to be enough. Rather, once the factory is fully installed and ready to roll, right? There has to be enough demand from the consumer that we need to pump out those chips, which in reality is not there. So from an Indian context perspective, I think going into a decent average technology to begin our semiconductors processor will be the most optimal, because not only we can do that at a relatively lesser cost, it will be full because of the local demand, and then it will result in a prosperous and a sustainable business model, right? So that was one angle. Now, independent to the technology of semiconductors, there is a second definition of technology, which is how latest technology trends, say ultra wideband as an example, or usage of say NFC as a near field communication technology, which could help us in a transaction which is contactless. For example, I'm going through a toll booth or going through a metro, right? How without any touch or any cash transaction, I can just walk by and the equivalent amount of toll or my cost of the travel can be deducted. So this is a technology, right? Same way, can technology help in creating a very secure ecosystem for me? When I'm entering into a car, the car automatically, when I'm near my car, the car automatically unlocks. And it only unlocks if I am near my car, knowing that I am the legal owner of the car, right? Versus opening for anyone. Or for that matter, in case a road hazard happens, can technology help in connecting the dots between ambulance, nearest hospital, and the remote location of the car in the middle of night, so that ambulance can reach and save the passenger when nobody to help, right? And we know thousands of cases like that globally, and also in India, people die on roads because nobody is to save them for multiple hours. So that is the second meaning of technology, where technology can save life, technology can make things more efficient. Another example, can technology be so nice that it tells me when to use the most power hungry equipments at my home, say washing machine, only operates automatically when the tariff is the least. And how the automatic tariff will kick in? When we know that the load distribution is actually the most balanced, and rather than at the peak time, this is happening in the middle of night, say. That is another use of technology, right? Another use of technology could be, I have solar panels, which are installed, and automatically they are managing the load sharing by sourcing electricity through the natural light, which is being created every single minute using sunlight, or using wind energy, or using any other renewable energy source, and then nicely balancing it. And in some of the good cases, which by the way is reality in many countries, including Germany, where you develop your electricity through, let's say, your house roof, solar panels, and you actually feed that back into the grid, and you actually earn money. So instead of paying a bill of 5,000, 10,000 rupees a month in typical Indian household, you actually generate that much of revenue every month, right? How exciting that sounds. That is another use of technology. So if we think technology as an independent way to improve human life and environment and comfort, our youth, our entrepreneurs, our industries, if they have more use cases, more application oriented use cases like that, they will be motivated to develop these products, which can be designed using semiconductors and electronics, because that has become the lifeline for everything we do today. Even a car, which used to be a mechanical device 10 years ago, today is loaded with more than 100 chips. Average car is loaded with more than 100 chips. Advanced car with the autonomous capabilities loaded with more than 200, 300 chips. And the average electronic content in a car is increasing at a very high double-digit CAGR rate. So to summarize this thing, I would say the more customer use cases emerge to help our people, to help our society, the more products will be designed by these entrepreneurs and industries. The more products being designed, the more opportunities they will fuel for manufacturing those products. And if everything happens in India, it automatically means that our fabs will be always in demand. So you will not make a fab which nobody is using. It was just created for the namesake. It will be a relevant part of the society and for the industry in India, which is just like a car factory or a scooter factory which is always loaded and always in demand. Same way, manufacturing of semiconductors in times to come, thanks to all these technology progressions and innovations, our fabs will be loaded, where different kind of chips will be coming out to serve different kind of purpose, right from a speaker phone or a Bluetooth headphone or to a mobile application or a smartwatch or whatever it is, right?
Thank you so much, Sanjay. I think that was a really enriching conversation that you have had with us, and the rise of cloud, 5G deployment, and all the technologies that you've just mentioned has created unprecedented demand for high performance computing. And the sizzling hot semiconductor industry, I should say, is very much working in coordinates with that. And the two schemes that we spoke of will definitely boost the domestic semiconductor and manufacturing to massive strategic advantages, and considering the factors such as low labor cost and vast production capacity, as you mentioned. So thank you so much once again for the insightful conversation, Sanjay.
Thank you so much. It was really about these.
So, audience, this brings us to the end of our conversation. Thank you so much for listening to us. Stay tuned to TechGig for all the latest tech happenings and updates. This is your host signing off.